Cleaning is a chore. It is repetitive, it is boring, and quite frankly, it is a waste of time that you could be spending doing literally anything else, like contemplating the heat death of the universe or looking at memes. That's why we invented the robot vacuum. A friendly little plastic disc that hums around your floor, bumping into chairs and eating dust bunnies. But there is a problem. Robot vacuums are slow. They wander around aimlessly, taking an hour to clean a room that you could vacuum in 5 minutes. This inefficiency is unacceptable. You are a busy person. You want a clean floor and you want it now. So you have a brilliant idea. Physics tells us that velocity is distance over time. If we want to reduce the time to near zero, we simply need to increase the velocity. So we ask the question, what happens if we modify a standard Roomba to clean your living room at Mach 23, also known as orbital velocity? The short answer is you don't have a clean floor anymore. You also don't have a floor or a house. And depending on the weather patterns, your neighbors might be breathing in the vaporized remains of your cat for the next 3 weeks. Let's do the math. Let's establish our parameters. We have a standard suburban living room. Let's call it 20 square meters. We have a standard robot vacuum. Let's call him Dusty. Dusty weighs about 4 kilograms and is made of hard plastic, rubber, and a lithium-ion battery. Normally, Dusty moves at a blistering speed of 30 centimeters per second. At this rate, assuming a random walk algorithm, it takes him about 60 minutes to achieve 90% coverage of the room. But you are an engineer with access to a particle accelerator and very little regard for safety regulations. You decide to upgrade Dusty's drive motors. You want him to cover every square inch of the carpet in a fraction of a second. To do this, Dusty needs to move fast. Specifically, you want him to move at orbital velocity. For those of you who skipped physics class to smoke behind the gym, orbital velocity is the speed you need to be going sideways so that when you fall towards the Earth, you miss. At sea level, this is approximately 7.8 kilometers per second. That is roughly 17,500 miles per hour. That is Mach 23. To put that in perspective, a high-powered rifle bullet travels at roughly Mach 3. You are proposing to fire a vacuum cleaner across your carpet at 7 times the speed of a sniper round. Now, there are some immediate engineering hurdles here. A standard lithium-ion battery cannot discharge energy fast enough to accelerate 4 kilograms to Mach 23 instantly. If it tried, the battery wouldn't propel the robot. It would simply detonate like a grenade in the charging dock. So let's assume you've replaced the battery with a hypothetical, indestructibly efficient power source. Maybe a miniature antimatter reactor, or perhaps just a drop of whatever energy drink college students consume during finals week. You place Dusty in the corner of the room. You hit the clean button. You step back. Actually, step back further. Maybe into the next county. Let's look at the aerodynamics of a living room. Air is a fluid. When you walk through it, the air molecules politely move out of your way. They flow around you. Even when a car drives down the highway at 70 miles per hour, the air has plenty of time to realize the car is coming and flow over the windshield. But at Mach 23, the air does not have time to move. The air molecules simply do not get the memo. When Dusty accelerates from 0 to 700-800 meters per second, he is moving significantly faster than the speed of sound. The speed of sound is essentially the speed at which air molecules can bump into each other to say, hey, move over, something is coming. Since Dusty is moving faster than that information can travel, the air directly in front of his bumper gets trapped. It can't get out of the way, it gets crushed. This creates a shockwave. But shockwave is too gentle a word. It creates a layer of compressed gas that instantly undergoes a phase change. In the first millisecond of the cleaning cycle, the air in front of the vacuum is compressed so violently that the temperature skyrockets. We aren't talking about a warm breeze. We are talking about the ideal gas law on steroids. Pressure and temperature are directly linked. When you compress a gas that quickly, the temperature in the shock layer, the stagnation point, reaches somewhere in the neighborhood of 2,000 to 6,000 Kelvin. For reference, the surface of the sun is about 6,000 Kelvin. So, before Dusty has even moved a single inch, he has created a crescent-shaped bubble of plasma in your living room that is 10 times hotter than the surface of the sun. The dust mites in the carpet are not sucked up, they are not brushed away. They are instantly dissociated into their constituent atoms. The concept of dirt ceases to exist. The concept of carpet also ceases to exist. Let's take a brief tangent to appreciate the horror of what we call aerodynamic heating. Usually, when things burn up in the atmosphere like meteors or returning spacecraft, it happens high up in the mesosphere, where the air is incredibly thin. There aren't that many air molecules to hit, but because the speed is still high, but friction is still enough to melt steel. But Dusty isn't in the upper atmosphere. He is in your living room, at sea level. The air here is thick, it is dense, it is a soup of nitrogen and oxygen. Driving an object at orbital velocity through sea level air is physically traumatic for the universe. The drag force equation is F sub d equals 1/2 rho v squared c sub dA. Let's run the numbers. Rho, density of air, is 1.2 kilograms per cubic meter. V, velocity, is 7,800 meters per second. A, frontal area of a Roomba, is roughly 0.01 square meters. If we plug that in, the drag force pushing back against Dusty is roughly 6,000 newtons. That is the equivalent of placing a fully loaded 18-wheeler semi-truck on the front bumper of the Roomba. And that's just the force required to push the air. The energy being deposited into the air is kinetic energy. The formula is 1/2 mv squared. A 4-kilogram vacuum moving at 7,800 meters per second has a kinetic energy of roughly 121 megajoules. To put 121 megajoules into perspective, that is the energy equivalent of roughly 30 kilograms of TNT. And because Dusty dumps this energy into the air in the span of about 0.01 seconds as he crosses the room, this isn't a cleaning cycle. It is a detonation. We have effectively built a bomb. But it's a weird bomb because the explosion isn't coming from chemical explosives inside the robot. The explosion is coming from the robot simply existing too hard in a specific direction. Let's play the tape forward. Time 0.0000 seconds. The clean cycle activates. The wheels spin. Time 0.0001 seconds. Dusty accelerates. The leading edge of the vacuum cleaner instantly vaporizes. The plastic bumper doesn't just melt, it turns into a cloud of carbon and hydrogen plasma. This plasma sheath glows with a blinding blue-violet light, emitting a blast of hard X-rays and ultraviolet radiation. If you are standing in the room, you are instantly sunburned. And by sunburned, I mean your retinas are cauterized and your clothes catch fire. Time 0.0005 seconds. Dusty is halfway across the room. The shockwave is expanding. Because the vacuum is moving faster than sound, the room remains silent for a microsecond, but the pressure wave is building. The air inside the room is being pushed aside so violently that it behaves less like a gas and more like a solid hammer. The windows don't shatter, they are pulverized into sand. The walls of the living room bow outward. The structural integrity of the wood studs and drywall fails immediately under the megapascal pressures. Time 0.001 seconds. Dusty reaches the other side of the room. He hits the wall. Normally, a Roomba bumps the wall, rotates 90 degrees, and tries again. At Mach 23, Dusty does not bump the wall. Dusty becomes the wall upon impact. The kinetic energy of the robot itself, all those megajoules, is converted instantly into heat and deformation. The robot, the wall, and the dirt beneath the foundation fuse together in a hypervelocity impact crater. Time 0.01 seconds. The shockwave finally catches up. The explosion happens. A fireball of superheated plasma expands outward from the center of your house. The roof is lifted off, not blown off, but lifted intact hundreds of feet into the air, riding a cushion of expanding nitrogen. The walls are blasted into the neighbor's yard. The floor, where the carpet used to be, is now a scorched crater of vitrified concrete. Your cat, who was sleeping on the sofa, sadly, does not make it. However, the cat is technically moving at supersonic speeds now, so in a way he finally caught that red dot. Time 1.0 seconds. The sound reaches the rest of the neighborhood. It sounds like a thunderclap from God himself. A mushroom cloud of dust, drywall, and vaporized plastic rises over the subdivision. Car alarms for 3 miles are triggered. So did it work? Technically, yes. If we look at the definition of cleaning, which is the removal of dirt and debris from a surface, then Dusty performed admirably. There is no more dust. There are no more crumbs. There is no more bacteria. In fact, Dusty cleaned so thoroughly that he removed the carpet, the subfloor, the foundation, the furniture, and the mortgage. You no longer have to worry about vacuuming next week, because you are currently being interviewed by the Department of Homeland Security about why you detonated a kinetic kill vehicle in a residential zone. This brings us to an important lesson in physics scale matters. Just because a little bit of speed helps you finish a task, it doesn't mean a lot of speed helps you finish it better. Physics is a cruel mistress. She has laws, and when you try to break them, she breaks your house. If you want to clean your room faster, maybe just buy a second normal vacuum. Or, just use a broom. It's slower, but it has a significantly lower risk of turning your living room into a jagged crater of radioactive glass. Thanks for watching, and remember, if your vacuum cleaner starts glowing blue, run.